Alright, so what I'm showing today is basically the mirror of the Birkees-de-Crone effect. So it acts in both directions, because if you could see this here up top, this blue line here is the ellipse, but this darker blue line here is the circle. And if you put an ellipse inside of a circle, it's basically the same thing as squaring it, because what you're doing is taking the standing frame of the circle and squishing it this way. It adds in volume, so it expands horizontally. So if I was to take this pendulum, say here, and take it from the radius, obviously, which is the center here, out to the side, then if I take that and have it pinned and drop it down, but keep the length the same, the oscillation frequency does not change. They're at a 1-to-1. But what has changed is by putting the pendulum down here at the bottom, then you can add one of these configurations up top here, which is a reversed Birkees-de-Crone. So as this swings out to the side, 45 degrees either way, that makes a full quarter. And that means that this has to be quartered in ellipse. So right now, dead center, it's 1-to-1. But as it swings to the side, 45 degrees, it reaches a quarter in speed ratio. So it's actually traveling 4 times faster. And because when this swings back, it starts off 4 times faster too. And that's to either side of the line, which is an eighth. So if you mirror that standing eighth by taking and squaring, because there should be obviously a 90-degree line here too, that shows that this line from the circle inside leaving the square is 22.5 degrees. This is 22.5 degrees. This inner one is 45 degrees. So that means that part of the wave projector is squished. And where does it go? Well, because you quartered it, then technically what you're doing is taking this length of this black square, the side of it, to the side of the circle here. So like this black circle that's outside of the black square, this is the circle that is at the bottom, obviously. And this circle here is the red circle that's inside. This square would be this first square out here on the side. And then obviously the second square is this one here. And that's where you've squished the circle. So what you've done with this one length here is add it to the side right here. And that means that the rate that the water slows down towards the end of the swing is less. So that means that you can increase it for distance, because it's an inertial frame, because you're traveling in a circle and then straightening it so it wants to fly out of the circle. And as long as it stops before it reaches, because you can see where I drew the new 180-degree line beneath it, so it's squared, it's the same size square as this square should be. And basically what you've done is shift it. So you erase a hole right here just before the end of that there, which adds an eighth obviously to your circle. This is full of water already and resisted by a turbine, and then allowed to return to itself as more water gets dumped in. But because you're not subtracting all of the water from the tank, then most of the water still free falls up, actually past that point where the hole is, because the hole's so small, and then falls the whole way back. So you're not losing anything from the total head height of the pendulum swing. So that means you can take this pendulum rig here along with this system that I showed you and then put it to a linear rack and pinion and have an underslung paddle that just moves linear straight back and forth in the tank, obviously. And that there, because it accelerates towards the end of the swing, but because this here is decelerating towards the end of the swing, then they're at a 1-to-1. And 1-to-1 is one frame of inertia, which is a standpoint mass. Because of this system here, the force exchange between the pendulum, which would be on this here, obviously, or well, I mean, on this here, and the output from the pendulum being here, then the pendulum on this end will be synced with the waves on this side, and the force projector is felt at 45 degrees, which squares your circle on the margin, because it's the same frame 1-to-1 as this, and this works in a frame of inertia or standpoint gravity. It also only works in this design too. And this water up top here was just to show basically how you've taken and dropped the height of the tank, but not the height of the water. Because wave volume is taken horizontally, so it's taken between the width, as where the pendulum oscillation is taken from the radius.